Welcome back with Gennaro Cuofano again, talking about his 9-layer AI stack. Welcome, Gennaro.
Thank you, Jason. Glad to be back.
After 5 minutes. Most AI analysis still compresses the ecosystem into chips, models, and apps, and your framework expands that into 9 distinct layers. Can you walk us through the 9 layers? If I remember rightly, energy, foundries, silicon, networking, compute, models, harness, distribution, and governance.
Yeah, absolutely. I do have people that have been pinging me over the years asking me about the AI, the AI ecosystem. And, the question that most came often to me was, is this like a bubble? And why are things like so circular, right? And I try to explain to them over and over, and that's why I turned these into like an ecosystem reading of where we are, that the reason why they see things necessarily as a bubble, and in the long term they might be right or whatever, but the point is, the reason why people see things like so circular, as if almost we have just like 2-3 players that are controlling the whole ecosystem, is because they don't understand how layered this ecosystem is, and the fact that we have like thousands of companies across the full spectrum that actually make up this whole ecosystem. So it's easy, as again, because we turn into a discussion where on a daily basis we use, I don't know, like Anthropic, OpenAI, Gemini, and the other stuff, and we say, okay, that's it, that's the whole ecosystem. It's not. And in order for those players to actually be able to serve us, they need to actually leverage all AI ecosystem. As an example, now that you're loving as well Claude, for Claude to actually work and be able to serve you the tokens, they had to close a partnership with SpaceX, because otherwise they would have missed the computing power to actually serve the tokens. So again, going back to the whole map, pretty much the key point is right now, the whole 9-layered stack of AI, it starts from energy and the physical infrastructure, because it's very easy to think, AI is just in the ether, as almost it comes from a place which is like a place which has unlimited resources. It does not. Our infrastructure, the way we have it, for instance, we do have a lot of data centers, especially if you look at US, there are like thousands of data centers, but all the data centers that we have are not ready for AI, because those data centers were done to actually leverage and actually store web data, which is not what we're doing with AI. So we're building the whole physical infrastructure to serve those AI models. So we're building what are called AI data centers. And by definition, those AI data centers are very, thirsty in terms of like energy, in a way that is quite crazy, because if you think about it, our grid is not able to actually enable those data centers to work at the scale that we need. So at the moment, there is like all the capex raise, where like those top players in the industry are putting this year, 2026. I do believe we're going to pass like $1 trillion invested in the infrastructure space, $1 trillion. So, and I repeat it because it's a number that is staggering. If you think about it, just like a few years back, $1 trillion was like something that was very hard to fathom, but that's where we are, because we're building the energy and physical infrastructure. And this goes back to what I was explaining, which is we are building the computer. The whole infrastructure that we have right now for the computers that we use, it was built in the 40s and 50s on the assumption that a computer is like a deterministic machine that does like, control things in a very narrow environment with the human in the loop. Now we're rebuilding the whole thing. And so we're starting like a second computing revolution, and the infrastructure that we have is not ready for it. So it's going to take us like 5 to 10 years just to rebuild this. And that's where we are in the first layer of energy and physical infrastructure, which is about,
which is really interesting, because I think a lot of people kind of come in thinking, oh, everything's changing tomorrow. But actually, there are physical limitations on how fast this is going to be able to move forward.
Yeah, and that's the whole point also of the map of AI, that the drone, where I show you that everywhere we look at every layer, there are like choke points and they're like bottlenecks, meaning that it's going to take us years. So again, first layer, energy and physical infrastructure, is going to take us 10, 20 years to complete at the level of scale that we need. So when they compare, for instance, AI to the web, I explain to them, this is not the web paradigm. It's completely different, because at the moment, we are not even able to cover for the physical infrastructure that we're building in the next 2-3 years. We are not even able to cover for the demand that we have today. That's the key difference, right? That's number one. Number two, again, if you look at the second layer, which is like the foundries and what I call also the packaging, right now a key issue is that if you look at the foundries, right? So we have like a company like TSMC, which is a key bottleneck that has kept like the GPU demand on track, but at the same time is also like not been pushing too much on the capex investment because by definition this industry is very volatile. So TSMC, being in business for a long time, they know that it might be very too risky for them to invest everything in the capacity that the old players are asking to the company. So this is another bottleneck. Interesting thing is not just like the foundries, meaning the GPU itself, is also everything that comes with it. Because right now there is no packaging to make like a GPU also work together with the CPU, because we need more and more memory due to agents. Because now we're in a place where those AI agents are no longer just fine with the regular GPU, the way NVIDIA produced it. They need different kinds of specialized GPU on the inference side. They have like a huge part which is about memory, and that is faster also and cheaper for the inference side. And then, of course, we have the silicon side, which is the third layer. And Jason, tell me the pace that you want me to go, because I will be able to spend hours on this, but I go fairly fast.
I'm expecting that you walk us through all of the layers one by one.
Yeah.
And then we'll come back to business and assistive agent optimization. So we're up to layer, what was it, 3 now?
Yeah, it's layer 3, which is like the silicon layer, which is again is another key part, and there we find like NVIDIA. Where are we with this layer? Before, when this AI industry started again with ChatGPT, we were in a place where with the GPU we could do like most of the workloads. Now we're in a place where with the GPU we're not able to do like all the workloads that we need. Because for people that look at the AI industry, remember that we have like 3 pieces of the pipeline. We have the research side, then we have the pre-training side, and then there is the other side, which is inference, which we actually use to actually serve models at scale, right? Based on that, of course, we have the classic GPU, but also NVIDIA is investing in other types of GPUs. For instance, they acquired in the last year a company called Groq, with a Q, not with a K, so it's not the company from Elon Musk, of course, which is a company that does inference and does it in a way that is way faster. In addition to that, on the silicon side, we have all the other players that are investing in it, because of course you have the TPU of Google, then you have like Trainium from Amazon, you have like many other things. Again, we could spend a lot of time just on this layer, but the key point is we are now moved on a place where the GPU is no longer enough. We need a different kind of GPU, and a different kind of GPU that is adapted for the inference at scale, which means when a user is going to be leveraging a model. And that's another part of the layer. Then we move up and we go to what I call like the networking, and also we could add like the protocols, because again, right now a cool thing to understand is no longer about the single GPU, is the way you actually put those GPUs together, both from the training side and inference side. Because again, if you look at one of the latest GPUs from NVIDIA, which is like the Vera Rubin, like this is like a stack. This is this rack who is like is going very close, like I think 100 GPUs or something like that. So there is the whole networking capability of connecting those GPUs together to do like both pre-training of very powerful model, and then on the other side also serve very powerful workloads. So this is where we are. It's no longer about the single GPU. It's about the networking architecture that enables the GPUs. For instance, if you're a Google, go for it, Jason.
No, yeah, you mentioned inference, and I'm thinking about my framing gap. I call it the framing gap, which is A plus B, therefore C, easy. A plus B, therefore J is something that I call lateral thinking that a human currently needs to do. But you're saying that the solution to inference for AI is actually not in the models, it's in the machinery behind it.
Mm-hmm. Yeah, absolutely.
Wow. Okay. Now, carry on. Sorry.
That's spot on. And again, like if you think about it, even going back to the example of Google and Gemini, Google has a TPU infrastructure that in many cases is also able to connect in a distributed fashion, meaning not all together in the same place, but different TPUs, even thousands of TPUs, to serve like inference at scale, which explains why Gemini is a very powerful model on the consumer side. And then, of course, moving up on the stack, we have like the compute capacity, meaning that, as you know, as I was telling you today, the reason why you're finally able to use Claude, especially for the business users on the lowest plans or like the free users, and the reason why Claude is able to provide like a free plan is because they're unlocked like compute space that before was not available because they closed different deals with Google, with Amazon, but also with SpaceX to free up compute that right now is actually a huge bottleneck. It's one of the most important choke points. And as I was explaining, it's going to take us like 5 to 10 years before we build the amount of compute that we would just need already today, based on the things that on the demand that we have. Because again, remember that the reason why sometimes agents don't work the way they should work is because they run out of tokens budget and they start making stuff up, or like, they forget the context. They do compaction because you cannot push too much token consumption. Therefore, you have to leverage memory. There are like all those aspects where compute is quite important. And then, of course,
and then the problem, of course, is supply creates its own demand, which is where we are now. Is that as soon as you give people the tools that they can use, then the demand explodes, and that's what's happened with AI on top of search. And so you're saying it's going to be 10 years before we've even got the compute to be able to fulfill what we're currently demanding. That pushes it even further down the line because we're going to demand more and more.
Yeah, exactly. And it's a great point. But if you think about it, like, Google I/O announced that they're going to try to start pushing agents in as a main way to actually have people communicate with search, which is a huge leap. But if you think about it, in order for agents to actually do everything they need, imagine the level of an amount of tokens that we're going to need. Which connect again with the sixth layer of the stack, which is the foundational models that, as I was explaining as well in our previous conversation, those foundational models are now.
Sorry, just to interrupt there. In fact, we've just got to level 6 out of 9, and you've just mentioned models as the 6th, and most people would have thought it's the only one.
Exactly. And that's why everyone is talking about AI bubbles, because they ignore the ecosystem that is behind. Also, like on the model side, there are like a couple of key points. Number one is that those models themselves are becoming like agents. They are becoming like huge agents, huge horizontal agents. Because, for instance, what companies are doing, if you take the case of Anthropic, they're actually training those models on the harness of the user. So using agents, using your computer, doing your own stuff, this data, of course, anonymized way and everything, but it's getting back into the model in order for the model to become better and better at controlling a computer and doing more things so that the agent becomes the computer. That's where we're going, right? In next 2, 3 years, 5 years, what we want to achieve is that the agent is going to be your computer. You're not going to think in terms of like, okay, I have a computer that I have to open and use as a human. You're going to have your agents that will be your computers. That's the transition that we're going. And of course, like another key point, like on the foundation models, again, this is at the frontier. In order for you to achieve that, you need the whole ecosystem behind it, because otherwise you're not going to be able to keep progressing those models the way we need them to do in the real world. Which connects a little bit with the other piece of the stack, the 7th layer, which is the agentic harness, right? If you ask me what is the most important thing, and let's say there are like, of course, there are like no moats in AI, meaning that all moats will disappear over time, because this is the way the industry is done. But if you ask me what is a key critical moat in the next like 2, 3 years, is the agentic harness, meaning it's everything that you do with an agent in a sandbox, right? Because right now you have an agent that is, kept, let's say, hooked within a sandbox because you don't want the agent to use everything that you have access to because it's still too dangerous. But in the future, one thing that you want the agent to do is to escape the sandbox, to be able to do like a lot of things that will make the agent like super like general. So for you to do like a lot of interesting things in the real world. So the agentic harness in that perspective is quite important.
Yeah, I'm talking about the delegation boundary, which is basically saying we're delegating as human beings to the AI. And in search, we're delegating the choice of the 10 links. In assistive, we're delegating the choice of the recommendation of 1 or 2 options. And with agents, we're delegating the actual action. So the harness is the key to the delegation boundary.
Yeah, exactly.
Jolly good, super. Well, I don't know, it's just added something to my personal
it's amazing
discussion.
It's exactly the point. I mean, delegation judgment layer will be like the most important elements of the next like 2-3 years. So we're going to be obsessing over it.
Yeah, and within my model, which is kind of AI assistive agent optimization, it's where does your business sit on the delegation boundary? A coffee shop might have 5% agents as clients, whereas a SaaS company like Dave Davis is going to be talking about might have 95%. So that delegation boundary, where you sit on it and how long you expect it to take for the agent to become your client and to what extent it will be a dominant client for you, is a huge business question. And I'm calling that AI era business engineering, which sits alongside what you're doing. That's a new business approach that we need to take. We're going to have to, all of us are going to have to change our business to some extent. Sorry, go ahead.
Yeah, 100%. There is one only thing which is sure, which is mutation, meaning like every SaaS company, what I say is going to become like an AGaaS, meaning like an agent as a service company, meaning that many companies still like a SaaS company would be super relevant, but we open another topic and yeah, they will transform, they will mutate, because again, if you think about it, you have an API for SaaS. An API has been something that the human has used for like years. Now an API is something that an agent uses, and the way an agent uses an API is completely different to the way like a human does. So it changes all business, but you also need to redefine the way you serve like the APIs to the like the business, like on the other side, to the agents, right? It's going to be completely different perspective, but that's where we are.
Brilliant. Okay, and so we've got, I think, 2 layers left.
Yep, and to close, I'll go fast on those ones so that we move forward. But again, another layer is the distribution and distribution surfaces, meaning that, again, right now, the next phase of the market is moving from chatbot to agents. So the agent is eating the chatbot, and then the agent is going to be swallowing the computer. So everything that you call a computer is going to be an agent. So that's where we're going. And in that case, of course, each company is going to, especially frontier company, lab, will have its own strategy. As you can see, like Anthropic and OpenAI are converging on the enterprise and coding space. Not even coding, because even Codex is not for coders, it's for everyone, even for marketing people. But right, they're converging in the same direction. Then you're going to have instead like Google with Gemini that is going to be more pushed toward like the consumer space. And so that's another layer. And then the last piece that has emerged is another of the pieces that has emerged together with the agentic harness in the last year is the governance. Meaning right now with Anthropic releasing Mythos, which was the latest model, was quite good in terms of like cybersecurity. And so there was a lot of noise around it. We cannot release it because it's going to be too dangerous. So we need to have like a preview release and everything else. This is quite interesting. Of course, what Anthropic is saying, they don't believe it. There is like absolutely like it's sincere on their part. However, I would say there are like other elements of it on the governance side, which the way on the frontier AI you release a model is going to become quite important, because if you release it in preview for a specific set of enterprise users, and then you close it for all the rest, as you can imagine, this will affect also the open source frontier of AI, because if you know open source, a lot of it comes from the fact that they use things like distillation and a mixture of experts as main things to actually bring like an open source model up to speed very quick to the frontier. So with the governance in place where the latest models are like super advanced, are not released to the broader market, but they are released in preview for a little bit of time, that changes a little bit the shape of the market. So you're going to see more and more companies also on the open source specializing in different directions where they can keep up and be like useful, versus before they would be like right at the frontier. So that's what we're seeing. It's another part of the layer which is quite important, the way those models are released, the frontier AI models are released.
Brilliant. Oh, I always learn so much from you, Gennaro. Now we've gone all the way up the left-hand side. Can you quickly go across the top, which is all of the different major players and what they have and what they don't have?
Yeah, and we could spend hours on this one. So I'll try I have tried to be super short, which I think connects also to another thing that we tackle, which is about the geometries, meaning that each of those companies is specializing and finding its own go-to-market in different direction, right? For instance, if you look at the case of Google, Google is the vertical case, right? Because Google is the one that has been using an approach where it needs to be across the full stack because it needs to reduce the cost per token because it needs to serve the consumer market. And then on the other side, there has been like another cool transition for Google, which finally, after years, it started to sell the TPU to the external market. A similar approach is going to be done by Meta, but Meta is going to be investing everything on the vertical integration for the AR race, right? The wearable, the AR race, the AR race. And then, of course, NVIDIA instead has a different approach, which is going to be like more horizontal. So they're going to try to be everywhere on the horizontal stack to actually get attacks across like the whole ecosystem. And then, of course, like Microsoft, Amazon, like have a very similar approach. And then I call SpaceX like the flywheel because it has a different kind of go-to-market where it leverages like the computing infrastructure that it has built to actually then unlock resources to be able to do the next run of compute resources and also to come up with a very competitive like frontier AI model. So we can expect from XAI to be back on it as well. And then, of course, we have Anthropic, OpenAI that right now I call it the lab posture at the moment. And then, of course, we have other players that are like more on the niche side. And then DeepSeek, I call it like indigenous because if you're following like the US versus China, of course, we are in a place where AI being also like a dual technology, meaning can be dual purpose technology, can be used for good and for bad. As you can imagine, it's going to also imply that you're going to have a Chinese stack that is going to try to be super vertically integrated, where China is going to be trying to build the whole ecosystem from energy up to the governance, within China. There is indeed news of the last days that how Huawei has announced that, for instance, they're able to do like the GPU at the cutting edge. That's what they're telling us. So Huawei is going to be like a key player that helps the China stack get like verticalized across the all layers of the AI map.
Brilliant. Okay, and one thing, sorry, I was thinking about this, which is your model, and I love this diagram, and it's showing where each of the big players is dominant and how much they own and how much they borrow and how much they're able, or where they end up. And I'm just going to share my screen because it comes back to this, which was part of my keynote for Google Marketing Live. There you go. When I'm talking about the algorithmic trinity. So search, information, LLM intelligence that LLM intelligence that allows the machine to have a conversation. It then needs the information, which is search, and then it needs to validate or verify, which is the knowledge graph. And that's the algorithmic trinity. All AI assistive engines run off those three at the moment. And I'm pointing out here that Google has all three and none of the others do. And that's a huge advantage to Google. So the algorithmic trinity for me is a foundational part of everything that I'm doing. And it sits across the activate algorithm area where annotation, recruitment, grounding, and display, and then the one state, i.e. who wins the click at the end of the day. Now we've got less and less clicks. Is it the imperfect click in search? Is it the perfect click in an assistive engine where the algorithmic trinity comes into play, or an agentic click, i.e. the agent chooses you, which is still the algorithmic trinity. So we end up with the algorithmic trinity for me being the decider of all of these three different types of engines. And you're now talking about the agentic click at the bottom. And then the next question is, number one, does this diagram make sense to you?
Yeah, it's very cool. I mean, I would say this is exactly the way we need to think about, AI, search and the transition that we're seeing, where, as you say, everything is becoming an agent. As you say, Google. The reason why Google it's winning on the consumer side is exactly because they have like the three parts in the stack. And if you look at the agentic commerce piece, like the reason why OpenAI has not been able to be successful at the moment is because Google has the product knowledge graph infrastructure that is quite super relevant. So yeah, it's exactly that.
Super. And then if we move over into OPIDC, and I know it's not a very delightful acronym, but it's the serving the client part. So you've won the client, you onboard them, you perform for them, i.e. you give them the service or the product they bought. Integrated suggests keeping them on board as a regular client. Devoted is the getting them to be an advocate for you. And then Codify is taking all of that business, what you're doing with your business, how you're being successful with your clients, how your clients are responding, their reviews, their testimonials, your FAQ, your sales calls, anonymized, of course, and then you codify it and push it back into the open web or into the bots and the algorithms by multiple means, traditional bots, Index Now, MCP, Web MCP, whatever comes next, to create the flywheel where you're codifying your business and feeding it back as corroboration and support that you're actually serving the clients in the way that the engines can then recommend you.
Yeah, very cool. Amazing.
Brilliant. Can you talk a little bit about the agentic side of OPIDC, i.e. where I've put people serving agents?
Yeah, I mean, this connects a little bit with the work that I do with the team at WorldLift. I think I spoke with Andrea Volpini as well, and Andrea is one of the brightest minds in the space. And I am lucky that I get a lot of daily inputs from him as well on that. And we do like a lot of work with very large enterprise brands on this front. But again, I think quite important mental model right now to keep into account when dealing with the agents, as we say, is no longer just about the pre-training side of it, because many are still thinking this is just about pre-training. It's not, as we say, this is about pre-training on one side, but then it's about the agentic loop. So the data that you put out there, for instance, on our side, with the team at WorldLift, we do a lot of work on the structured data and knowledge graph piece, right? But why do we do that? Well, we do that because it helps not only like a model, like a frontier model, to actually learn what your brand is about when you put your data out there in a structured format, which is machine readable. But we also do this because we need to close the agentic loop. And if you're an agent out there, let's say you're Google in AI mode, and the Google AI mode next year, if you ask me what's the most important transition, it needs to become an agent, right? That's what Google AI mode needs to do right now, because right now it's still like a chatbot interface. It's still like an old type of ChatGPT. It's cool. We're starting to use it more and more. But again, the challenge for Google is how do we turn these into like an agent? And I would say Google is completed the journey into becoming like an AI first, like an AI company 100%, right? So in that perspective, when you put data out there, connects with your framework, you're putting out like a curated data set that helps the agent close the loop, because they need to find the information that they can trust, they can verify. And that sort of information, you need to be able to also control it in a way with your brand, so that you can, again, specify what the brand is about, but also what are the different journeys that the user can take through an agent. Because the agent on the other side, it's trying to find all the ways the user can discover the brand, discover the product, and also in the near future transact and so buy the product. So how do you give the agent, like for instance, our obsession on a daily basis with the team at WorldLift is how do you give the agent what it needs to actually serve the user, right? So in that perspective, having like the machine readable data that helps the agent close the loop is the most important aspect and the most important mental model that you need to have.
Brilliant. That's the perfect ending. Thank you so much, Gennaro. That was absolutely brilliant. Thank you, everybody. See you in the next session.